theorems is going to help us do problem number 5 for section 1 of chapter 7. So the first theorem says is, well, like the last problem, problem number 4, it was saying if we have a right triangle, the only way we can get to a right triangle, so if we want a right triangle, the only way to get there, the converse of the Pythagorean theorem, is if our two smaller sides squared equal the bigger side squared, then you have a right triangle. Then you have a right triangle. Well, what if we don't? What if the c squared, this number, is actually bigger than, so it's bigger than the two smaller ones squared. So if the hypotenuse is bigger than, which it wouldn't be the hypotenuse then, but if the bigger side squared is bigger than the sum of the two smaller sides squared, so if this is bigger than, then it's obtuse. Then the whole triangle would be obtuse. So it's not a right triangle, it's an obtuse triangle. Okay? Means this angle right here is bigger than 90 degrees. Okay? So if the c squared is bigger, c squared is bigger, not just c, but c squared is bigger, then it is an obtuse triangle. And then theorem 68 says that, okay, if the c squared is smaller than, I could write it like this, or I could write it like this. A squared plus b squared is, c is smaller than, c squared is smaller than. So if your largest number squared, so whatever, look at your three numbers, whichever the largest is, that's your c. And if you square that, if that number is smaller than your other two squared added up, then it is acute. Okay, which means that this angle is smaller than 90 degrees. Okay, so we're going to play those two theorems in problem number 5 in order to classify triangles. So problem number 5 is to classify triangles. So we're going to look at three sides of a triangle. We are going to square the two smaller sides and see if that equals the larger side squared. So we're going to square these, get 36, we get 121, which is what? 157. And we're going to see what 14 squared is, which is 196. And so 196 is actually bigger than 157. 196. So that means because the bigger side squared is bigger, it is obtuse. So it's all based on that bigger side. So it's all about that bigger side. So here's another one. You can try it yourself. You can pause the video and try this one yourself if you want. So take the two smaller ones, square them. Okay, add them together. So 49 and 64 is almost 50. 113, right? Yeah. And then take the largest side, square it, 81. So what is this number compared to these two added together? Well, that's smaller than, right? So that's smaller than, so that means that since this number is smaller than those two combined, then it is acute. So it's all based on what that larger number squared is. Okay, so if this larger number squared is bigger, then it's going to be obtuse. If it's smaller, then it's going to be acute. And if it's the same, then it's going to be right. Okay, so that's problem number 5. I guess that was your got it here. Let me give you a got it real quick. I got it for that is take, how about these numbers? 0.3, which you can square 0.3. It's fine. 0.4, which you can square 0.4. And 0.6. You could test that. Okay. Or you could do these three, square root 11, which you can square that, square root 7, which you can square that, and 4. Okay, which is the biggest number here? So the biggest number here would be 0.6. Okay, so that would be your large one. Maybe you don't know that, but it's 0.6 would be your largest one because it's closer to 1. This is 0.6 would be 60%, closer to 100%. What number would be here? Well, the square root of 11, that's smaller. We know 4 is square root 16. Okay, so this would be the largest, right? Square root 16 is bigger than these two. Okay, so 4 is your largest. Okay, so you can go ahead and try that on those two.